Alright guys, welcome back to another video. I am reading Machine Learning by Tom and Mitchell, pages 90 through 95? Yeah, 95. Middle of 95. So all these pages refer to or explain the concept of the gradient descent rule within the delta rule, or gradient descent within the delta rule. And basically, if we imagine our machine learning algorithm and we think of a ball rolling down a hill, what gradient descent does is it's trying to reduce the error of your algorithm. And it sets the weights in order to reduce that error. So in this analogy of a ball rolling down a hill, the hill is your error surface. A landscape where each point represents a possible settings of weights and the error you make from those weights. The ball is the current weight vector. So your model is weights. And as the ball rolls down the hill, you're trying to get to the point where the ball reaches the absolute minimum. Basically, the bottom of the valley is where that error is going to be the minimum error. The only problem is you don't actually know where the ball is before applying this. You don't know where the ball is in relation to the error. You might know the error, but you don't know exactly how to get there, if that makes sense. And then the slope is the gradient of the error. It tells you, it tells you which direction you need to go. So do you need to go further this way? Do you need to go further that way? Do you need to, how should you move this ball? And it does it in small steps, thousands of steps, in order to make sure you're going in the right direction, to be as efficient as possible. So that's what it does. I don't think getting into these pages, I don't think getting into all the equations is necessarily worth it for this video. Because that's what it's describing, that's what it does. So you can just understand it. It helped me understand it a lot better. They also go into a couple ways in which you can do that. Again, the difference between a standard gradient descent and a stochastic gradient descent. Again, I mean, I can go over them. So in a standard gradient descent, the error is summed over all examples before updating the weights. Stochastic gradient descent weights are updated upon examining each training example. So it's pretty easy to understand. It's nothing complicated there, and it goes into each of the ways you can do it. And then to sum up the basically what it went over, it goes back to the perceptron training rule versus the delta rule. For the perceptron rule, it updates weights based on the error in a thresholded perceptron output, meaning it's binary. The output of the perceptron is either 0 or it's either -1 or 1. It's binary. Whereas the delta rule updates it on unthresholded linear combinations of inputs. The way they converge is different. The perceptron training rule converts after a finite number of iterations. So it converts to what it thinks the minimum error is after it's iterated a limited amount of times, provided that the training examples are linearly separable, meaning you can put a line or a hyperplane and separate the examples. The delta rule converges regardless of whether you can separate those linearly. Yep, and then it goes into a third possible algorithm that I'm not going to get into because it's a small variation. In any case, that's the video. Thanks for watching if you watched, and hopefully it helped you. It helped me understand it a lot better. Yeah, and see you in the next video.